Hi, this tutorial is part of the alkanes topic. We're going to look at free radical substitution reactions and in particular the synthesis of chloroalkanes. So I'm going to start by looking at some keywords that are linked to this topic so that you understand what I'm talking about as I go through the tutorial. So free radical substitution is the name of a mechanism how two chemicals can react together. So in this case we're going to take an alkane and a halogen and react them to form a halogenoalkane. And reactions can go via lots of different mechanisms, and you're going to come across lots of mechanisms in your organic chemistry as you go through your A level. So first of all, the term free radical. A free radical is a chemical species, so just like you can have an atom, an ion, a molecule, you can also have a free radical. And a free radical is a particle that contains an unpaired electron. So there's your definition, a particle with an unpaired electron, and your example I've given you is a chlorine free radical, and it's represented using a dot. So you know that there's a free radical if it's got a dot next to it, and that represents the unpaired electron. So next, substitution. Substitution is a reaction where part of the compound is substituted for something else. So something will come in and join onto your molecule and something else will get pushed out. So there's been substitution overall. Okay, next keyword is homolytic fission. So fission means breaking bonds, and homolytic means broken in the same way. So I'll show you what that means now. So to show you what homolytic fission means, I've drawn out three equations for a molecule, A bound to B, and I've written that 3 times, and I'm going to show you how that bond can break to give you A and B separately. So there's 3 different ways that this can happen. First of all, your electrons in this covalent bond could move onto B. That would give you B is now negative because it's gained lots of electrons, and A is now positive because it's lost the electrons that were in this covalent bond. So a different way that this bond could break is all of the electrons in here could move on to A. That would make A negative because it's gained the electrons from the covalent bond, and B would then be positive because it's lost the electrons that it was sharing in that covalent bond. And the third way is for the covalent bond, being a pair of electrons, could split so that one electron goes that way and one electron goes that way. That would give you A with an unpaired electron and B with an unpaired electron. So the first example up here would give you a positive ion and a negative ion. This one would give you a negative ion and a positive ion. This one would give you 2 free radicals. So homolytic fission is when a covalent bond breaks so that one electron goes to each atom. Okay, and finally a photochemical reaction. So the synthesis of chloroalkanes via free radical substitution is an example of a photochemical reaction. And a photochemical reaction is just a reaction that requires UV light to get it started. So before we go any further and look at the mechanism, just make sure that you understand exactly what those 4 key terms mean. We're going to talk about free radicals quite a lot, and I am going to show you the homolytic fission and how that actually happens, although it's not required for you to be able to draw it out. It might just help you to understand. So the reaction we're going to look at is methane reacting with chlorine to make chloromethane and hydrochloric acid, or hydrogen chloride. So the reaction itself happens in 3 stages, and you do need to know the names of the stages in the reaction. So the first one is initiation, and in initiation you will start with something that isn't a free radical, so something that doesn't have unpaired electrons, and you will produce free radicals, so you will make something that does have unpaired electrons. And this is the part that's photochemical, that requires the UV light to get it started. So next is the propagation step, so this is where the chain reaction takes place. So the reaction starts with the free radicals produced in this step, and then it produces other free radicals which can go on and react, because free radicals are very, very reactive. And then finally you've got the termination step, where your free radicals that are floating around in the reaction react with each other to give you something that is no longer a free radical, and that stops the reaction. So you might be given the overall equation, you might be asked to write down the equations for the initiation, propagation and termination steps. So you need to know how they would be represented as a chemical equation. So I'm going to go through each of the steps in turn for the synthesis of chloromethane. What I'm going to do is at the top I will show you exactly how the reaction takes place in terms of the movement of the electrons, starting with the homolytic fission of this chlorine-chlorine covalent bond. But further down I will then show you how it would be written as an equation, and that would be what you'd need to do in your exam. So you are not required to show the movement of these electrons at all. So I'll make that quite clear as we go through. Okay, so the initiation stage is the bit that makes it a photochemical reaction. So this chlorine-chlorine bond can be broken with the energy that's in UV light from the sun. So the UV light comes in and breaks that chlorine-chlorine covalent bond. And this is where you get the homolytic fission of that bond. So the bond breaks with one electron going onto that chlorine and one electron going onto that chlorine. Now just to explain the weird arrows, this is a single-headed arrow rather than a usual double-headed arrow. So an arrow like this represents the movement of a pair of electrons, whereas an arrow like that represents movement of a single electron. So that's why we use these particular arrows with free radical substitution reactions, because we're dealing with unpaired electrons. So once this bond's been broken in that way, we then get a chlorine radical on one side and a chlorine radical on the other side. So that's how that first step actually happens. In your exam, you might be asked to outline a free radical substitution mechanism, and for the initiation step, all you would have to do in that case is write this as an equation. So chlorine molecule, under conditions of UV light, breaks into two chlorine radicals. And that would be all you're expected to write for your initiation step. So now that we've got some free radicals, these can go and be very, very reactive and cause the chain reaction in the propagation step. So that's what we'll look at next. Okay, so as I said, propagation steps are like a chain reaction, and that means that you can have multiple propagation steps in a free radical substitution reaction. So the first propagation step that you would need to show is the chlorine radical produced in the initiation step. That will react with your other reactant that's in your vessel, which is methane. Okay, so again I'll show you using movement of electrons how this actually works, but just note you are starting with a free radical. This is a propagation step, so you should end with a free radical as well. Okay, so what happens here is the free electron on chlorine moves over, and this bond here between carbon and hydrogen breaks. So what's going to happen is one of those electrons is going to go here, and this is bond formation between H and Cl, so this is where you make your hydrochloric acid, and the other electron from that covalent bond goes onto the chlorine, so we get homolytic fission here as well. So that would produce your chlorine and your hydrogen are now bonded together like that, and you've now got carbon with 3 hydrogens on it, and a free electron has moved onto that carbon, so it is now a free radical. So this is your first propagation step. Now if that looks confusing, don't worry about it. If it looks like something you might grasp, have a little look at it, see if you can figure out what's going on, but that's exactly how it happens. If you would rather just learn the equations off by heart, that's absolutely fine. So to represent this, you would have a chlorine radical reacts with one molecule of methane, CH4, producing HCl and a methyl radical. So that would be the equation that you write in your exam. So now this methyl radical that you've produced is now free to go on and react with another molecule of chlorine, and that would be your second propagation step. So I'm going to clear this and show you propagation step number 2. So I've just left that original propagation step up there, and we'll start again with a new step. So that bit, it would be all you need to write for propagation step number 1. So now we have got a methyl radical and this approaches another molecule of chlorine. And now we get a very similar thing happen as before. So this chlorine-chlorine bond is going to break, and one electron is going to go into this chlorine, and the other electron is going to go over here to start to form a bond between this carbon and this chlorine, and the free radical on the methyl, that free electron there, is also going to come in. So just to show you what that means, because you've got this electron coming from the chlorine and this electron coming from the carbon, this is a shared pair of electrons now, so this is how you make a covalent bond. So that would turn into your, what was a methyl radical, its new covalent bond, and the chlorine, and the chloride radical that's now left from here, where you've got electron being put onto the chlorine. So as an equation that you would have to write in your exam, we'd write it like this. So you've got the methyl radical reacting with a chlorine molecule to make chloromethane and a chlorine radical. So again, if you want to have a little look at that mechanism with the curly arrows, try and figure out what's going on, that's great. Otherwise, just make sure that you can remember to write this equation as propagation step number 2. So there's your exam answer for propagation. And just to reiterate, you've started with a radical here, you are ending with a radical here. So you start with your chlorine radical, react it with methane, and you produce a methyl radical. Your methyl radical reacts with chlorine, produces a chlorine radical, and that chain reaction can continue. So this chlorine radical can go and react with some more methane and make methyl radicals, and the methyl radicals can react with more chlorine, make more chlorine radicals. And that will continue to happen until you've got a huge amount of radicals, and then it becomes a lot more likely that actually the radicals will crash into each other rather than into something that is stable. So that is where you get your termination step, and that's what's coming next. Okay, so your termination step, in this case you take 2 radicals, react them together, and you form a stable molecule. And there are lots of radicals available, so there are lots of radicals that could react to give you a stable molecule. So you could have your chlorine radicals, they could combine to give you a chlorine molecule. That's a perfectly acceptable termination step for that reaction. You could have your methyl radicals, they could combine to give you a molecule of ethane. You could have one of each. And you'd get another chloromethane. So you need to make sure that you are able to write a number of termination steps for a free radical substitution reaction, and there's 3 possibilities for this reaction. Okay, so finally, just before we finish, just want to point out the fact that you could get further substitutions on a chloromethane molecule, so it depends on the conditions that you use for the reaction, and I'll show you what I mean by that. So you could carry this reaction out and you could use excess of the chlorine, or you could use excess of the methane, and depending on which conditions you use, you will get different sets of products. So I'm going to start with the excess methane first because it's simpler. So if you take your methane and you react it with chlorine, if you've got lots of methane in there, all your chlorine will be used up pretty quickly, and the only product you'll end up getting is the chloromethane. However, if you use excess chlorine, so we're going to look at this one now. First of all, you would get your methane, it would react with chlorine, and it will give you the chloromethane and hydrochloric acid. But then, because you've got excess chlorine in there, your chloromethane could also react with chlorine, and that would give you dichloromethane. And then if you've still got more chlorine, your dichloromethane could also react with chlorine. That would give you trichloromethane and hydrochloric acid. And then if there's still more chlorine in there, your trichloromethane with 3 chlorine atoms on it would react with another chlorine molecule, and you would get tetrachloromethane plus HCl. So you're likely to be told what the conditions are in the reaction before you talk about which products you're going to produce. So excess methane's dead easy, your main product will be chloromethane. Excess chlorine, you will get further substitutions. So the first substitution that we've just looked at in detail, and then each of these hydrogens on your chloromethane can eventually be replaced by another chlorine until you get as far as tetrachloromethane. So that's the end of your first tutorial on free radical substitution. There is a second tutorial on free radical substitution looking at the ozone layer and the breakdown of the ozone layer using CFCs, so that would be the next one to watch. So please make sure that you've got your lecture notes and you've completed your post-tutorial quiz before the next lesson. Thanks for listening.